Good morning, everybody. How are you today? I hope you're doing particularly awesome. Welcome to Quantitative Literacy Math 1111, and we are in our fourth lesson of the year. We are attempting to do our last lesson before we have a test series next week, and I want to talk to you a little bit about that test series, how it's structured, what to expect, so on and so forth. I'll mention certain things that dominated my teaching career many times. And one of them is the more you make the game like practice, and the more you make practice like the game, the more successful you are going to be. For those of you with an arts background, imagine if you practice like crazy for the play Once Upon a Mattress, and then you did Bye Bye Birdie. Nobody would be prepared. For those of you who are athletic, imagine if you were preparing to play baseball and you practice baseball all the time, and then they gave you you went and you played a game of football against another team. Forget it. You're not going to do well. Now, obviously, those are major exaggerations, but you want to make sure that as you structure your lessons and your prep materials for a test, that the kinds of things that the students are going to be expected to do are included in that work. I despised, and that is not too strong a word, when I was a student in school and the teacher would say the test is going to be on X, Y, and Z, and then they gave us a test on maybe X, A, and B. And I would be like, you got to be kidding me. You never told us this was on the test. So I do all this studying and it doesn't do me any good. So you can rest assured that between the videos that you've seen so far, particularly paying attention to the practice and the review questions, because I make review questions on there because I think the concept on those questions is a critical concept to know, so we hit it many times. And then, yes, to some extent, the finishing the classwork kind of questions you do that you submit for a homework grade, and then also just the problems that we do in class. Yes, those are typical, and there will be test questions like that. But I try to summarize and pull all of that together into some pre-tests. And the pre-tests are already up on Moodle. If you can do the pre-tests, every question on the pre-test, and you can, look through these videos and say, I'm comfortable with all of this kind of stuff, I do promise you that you will be able to handle anything that you're going to see on the test. Okay? It's extremely important that you know that. I am not one of these teachers who leaves to chance your preparation. Your preparation will be ordered and guided for you, and if you follow the steps I present and you do your work, you will be the one who kicks butt. Okay, so let's see what we got going on here for today. Well, typical agenda: praxis, prep, review materials, and classwork contemplations. I think today's lesson will be a touch shorter than many lessons because you have a quiz to take at the end of class today. Okay, solving equations, test-taking strategies. That's one of the things that we're going to see on praxis. That's that one where we can always check the answers and see if we're given an equation. Pythagorean theorem, area of a polygon, and probability. I can tell you now, having made up the test, that 3 of those 4 questions will be on the test. Okay. Find the area. So when we go to find the area of this figure, remember, area is what's on the inside. Go ahead, get started. Remember, stop and start. Okay, so since area is on the inside, what I see is a big rectangle on the inside and 2 triangles that are also part of the area because of what's inside them, and they're on either end. So just to get it out of the way, the first thing I'm going to do is find the area of that rectangle in the middle. It's 9 times 14 because area is length times width. It's 116 square meters, and mentally or on the paper, I'm going to put it on the side. I'm going to leave that alone, and I'm going to start thinking about the triangles for a minute. Now, the formula for the area of a triangle is half the base times the height. And I notice that I have my height here at 9, but I don't have the base. In order to find that base, I'm going to need the Pythagorean theorem. And we've already talked about the fact that you can do a squared plus b squared is c squared, but I'm partial to the leg squared plus leg squared equals hypotenuse squared. Either one works fine. So in this particular case, the legs are the 2 pieces that make up the right angle, and the hypotenuse is always across from the right angle. So 9 squared plus n squared, because I don't know that horizontal piece, is equal to 15 squared. Then just start crunching the numbers. 81 plus n squared is 225. Subtracting the 81, n squared is 144. That's comforting because n, the square root of 144, is then 12. So I put 12 into my figure, and now the area of that rectangle is half the base times the height. So it's going to be half of 12 times 9, which is going to be 54. So the total area on the inside is going to be 116, what we put aside for that rectangle in the middle, plus a 54, plus another 54 for the two triangles on the end. And you know, if you wanted to look at those two triangles, kind of move them around a little bit, rotate it, slide it over, you could say, hey, wait a minute, that makes up a whole rectangle. And it does. So you could look at it that way, and that's why we do the 54 twice instead of just once. Okay, next up, go ahead. Always remember to stop and start. Okay, so solving the equation, the answer is -4. Now, how can you do it? There are two ways that you could do it. The one thing that I can tell you about the two ways is that you should never, ever, ever miss a question that has an equation and then the choices are the solutions, because you can always just substitute them in. Now let's take a step back, solve it the right way. Tricky part of this is the part where students will mess up. There's two places. First, students will think that because you're the subtraction symbol here, which I like to look at as a negative, but let's look at it as a subtraction. You can do it either way. They'll say, oh, I need to add 7 to both sides. No, absolutely not. This 7 is positive. We always peek in front, like Mr. and Mrs. Smith gave you that speech already. In front of the 7 is a positive, so we need to do the opposite, which is a minus. And then when I minus 7 to both sides, the second possible mistake occurs. What kind of 2x is this? Well, that same idea about Mr. and Mrs. Smith. You peek in front, you see a negative in front of the 2x. So that's -2x is equal to 22. Dividing by -2, I get x is equal to -11. That -2 is the great danger moment Steve Irwin always talked about. It's the second most deadly type of equation problem in the whole world. One little bite from this beauty, you're a goner. So always remember to bring down that -2. Also remember the 7's positive. The negative has absolutely nothing to do with that 7. Okay, but you can always just check the answers, okay? I checked the 4. Nah, doesn't work. I checked the -11. Yes, does work. Why did I circle -4? Huh. The answer shouldn't be -4. It should be -11. There's your proof in the pudding there, okay? That it's -11. Sorry about that mess up before. That was probably the answer to the last time I did this, and I never moved the choice. And the last one, 15, does not equal 29. So the correct answer here is B, -11. Let's be clear on that. Okay, next up is a probability question. Now, we haven't talked much about probability, so I give you a little hint in the direction here. The probability of any event occurring, E, is the number of ways to do that event over the total number of possibilities. We've only done this once before. I would not feel comfortable going into a test only having covered a question like this once, so we're going to do it again. Go ahead. Find the probability of D. Well, the probability of a D is 1/7. And again, I messed up where I put the answer here. It should be 1/8. This is to make sure that you are aware and fully functional on these things. The probability of D is 1/8. So we should take this particular answer here and slide it up just a little bit. In fact, you know what? Let's do that. Mistakes here a little bit. Let's move her up. There. Good. And I'll also go here. And it's not always easy to get to just to see. There we go. Corrected for future posterity. Okay. So let's continue these that we have on this particular figure. The first one was, according to this, to find the probability of D, and that was 1/8. That's so much better. But then I come up with some more questions for you to do. Round and round we go. Probability of A, probability of B, probability of C, probability of X, probability of A or B or C. Go ahead, fill those 5 out. Okay, so as I look at this, I see 3 sections labeled A here. So the probability of A is 3/8. Remember, there's 8 sections total. Next, the probability of B. I see 2 sections there. So it's 2/8, which reduces to 1/4. The probability of C. I see 2 sections. So 2/8 reduces to 1/4. The probability of X, I don't see any X's there, which makes this an impossible event. So that probability is 0. And then an A or a B or a C, starting with this A going counterclockwise. 1, 2, 3, 4, 5, 6, 7. So it's 7 out of 8 regions are labeled either A or B or C. All right, so there's the praxis practice, and I can tell you you're going to have at least 3 of those on your upcoming test. Plus, I took them right off old praxis exams, so I think it's super critical for you to be able to do these questions so that you can pass that test and forge your future teaching career.